Welcome back. In the previous section, we saw how to create arrays. Okay, that would be the way of creating them standardly. Okay, but there are times where you have a very large dimension or a very large size of array you need to create, and the way you want to fill in the data there is by using some for loops, okay, or while loops. You may not understand what that means, but you will understand. You will understand later. Okay. So there are built-in functions in MATLAB that enable us to initialize arrays very rapidly of any given size, okay, that follow a certain pattern. You may want to create an array the same way I did when I created A using Randy, just to illustrate something or just to try something out. You may not always want the values there to be some form of standard value, okay, that you use. Just want to generate an array. These functions come in handy when you want to do that kind of operation, and much more, which you will discover when you begin to use MATLAB professionally yourselves. Okay, so let's start with the zeros function. Okay, let's start with the zeros function. Well, the zeros function, if I just press enter, zeros does what it says. Okay, it's just zero everywhere, right? So if I say A is equal to zeros, it gives me an array. As you can see, it gives me a 1 by 1 value, 0. That's all. But then I can use this zeros function to have an array of any given size, okay, which will be filled with zeros everywhere. And this is the way it functions. Initially, I can say A is equal to zeros of 2, for example. When you indicate a singular input argument into the function zeros, the way I have done, okay, just 2, MATLAB interprets it as you wanting a 2 by 2. So if you say n there, it will be an n by n matrix. So this will give us a 2 by 2 matrix of zeros everywhere. Okay, so what does it mean? If I enter 3, then it's a 3 by 3 matrix with zeros filled everywhere. If you want a matrix that have a different value, different number of columns, different number of rows, then you need to indicate, for example, 3, 2. So the first argument here will be the number of rows, and here will be the number of columns. And if I press enter, that's just what you get: 1 2 3 1 2. Okay, but the matrix is filled with 0 everywhere. Okay, so this is a good way of initializing a particular matrix, which you don't want to have any data initially, and that you will fill the data progressively, for example, following a for loop or a certain pattern. Okay, good. So that's that for zeros. We have similar functions like 0. They obey exactly the same principle, exactly the same mindset. Okay, you have ones. So ones, if I press enter, it just gives me 1. It does what it says. Okay, it's just a value of 1 everywhere, right? Ones of 2, the same way with 0, will give me a 2 by 2 matrix filled with 1 everywhere. Okay, ones of, let me put a vector this time around, gives me a column vector, right, of 1 everywhere. So you can just do, okay, anything. Let's be crazy. 8 by 8, it gives you an 8 by 8 filled with, hey, that was not professional. Okay, this should be enough, right? Will give you an 8 filled everywhere, right? So that's it. And then another one is the command I. If I press enter, it gives me 1, but it is not like ones. Okay, I here stands for identity. If you've done a little bit of linear algebra or high school mathematics, in fact, does it start with high school? Maybe. So if you've done that, then you will know I is an identity matrix. Okay, I stands for identity matrix. The first term in an identity matrix is 1. Okay, and identity matrix is a matrix that has 1 everywhere in the diagonal, but in the main diagonal, I should indicate 1 in the main diagonal and 0 everywhere else. Right? Good. So let's try to see that. So if I say I of 2, what does that give me? 1 in the diagonal, the main diagonal, and 0 everywhere else. Let's look at that with 3. 1 in the main diagonal and 0 everywhere else, right? Uh, what about 3? Oh, let me go to 4 first. Again, 1 in the main diagonal, 0 everywhere. Then let me take 4 comma 2 and let's see what happens. It is still 1 in the main diagonal. Okay, the main diagonal are the terms where the number of the row and the number of the column are the same. So 1 1 is a value in the main diagonal. 2 row 2 column 2 is a value in the main diagonal. Row 3 column 3 is a value. So the main diagonal values for this I command is 1. Okay, no matter how you indicate the dimension, it will always be 1. Sorry about that. It will always be 1 in the main diagonal and 0 everywhere else. Good. So that is the I command. So let's see 2 more. Okay, and we're good to go. We have the rand command. Okay, the run enables you to have, let me just press enter. Okay, it gives you any number between 0 and 1. That is what run does. It gives you a random number. So if I say rand again, it will not give me the same number. Okay, it gives you a random number found between 0 and 1. Okay, so rand, if you say rand of 2, you will have a matrix. Let's change the format again, please. Format short v. Good. So if I say rand of 2, that would be to get a 2 by 2 matrix of random numbers found between 0 and 1. Okay, if I say 3 comma 5, oh, the values are too big, but you should know how to interpret this. Okay, when the command window, when the matrix, the array you have to display on the command window is too large, this is the way MATLAB will give it to you. So it tells you the values that are here are from columns 1 through 4. So this is 1 2 3 4. Then down it starts with column 5, because here we have 5 columns, right? But all of the data there are values found between 0 and 1. There is another one which we used when we started this, called randy. Okay, randy is a random number for integers. So the first term in randy is for you to indicate, as you can see here, right, what is the maximum integer. The maximum integer, I will say, for example, 5. If I say 5, it means that I want values, integer values, that go from 1 to 5. Okay, I want integer value that go from 1 to 5, and if I just take that, it can give me any integer between 1 and 5. Enter another any integer. Okay, it's random. Okay, so let me take 80. Okay, it gives me any between 1 and 80. That's the principle. Okay, so now it is after you've indicated the maximum value that randy functions exactly like zeros, like ones, like rand, etc. So after I've indicated the maximum value, if I say 2, just 2, then I want a 2 by 2 matrix. Okay, it will give me a 2 by 2 matrix of values found between 1 and 6. And then let me say 3. Okay, it gives me a 3 by 3 matrix of values found between 1 and 6, as you can see. Okay, so now let's, for different rows and different columns, I'll say 3, for example, 2. That's it. Okay, so let's change here. Let me say 2. Okay, so it will give me just 1s and 2, because its value is either 1 and 2 in this case, right? It's either 1 or 2, but it will give me a 3 by 2 matrix. This indicates the size, or yeah, the size of the matrix that we are willing to create, right? So that's randy. I said we had 2 more to go. Let me just add the last one. Okay, the last one, which is more specifically for vector creation. Okay, and the command is LinSpace. Very handy command. Oh my god, I can't count the number of times I've used this throughout my baby programming life. I can't count the number of times. So LinSpace enables you to have a uniformly distributed number of values within a particular range. So for example, this is the way the data is. If I say A comma B comma C, that's the way LinSpace is. A here represents the lower. Oh, there's something that didn't show. Please, before coming to LinSpace, let's look at the last thing with Randy. Okay, Randy, you are not compelled to only go between 1 and 6 for the integer value, okay? If you want the values to vary between, for example, 5 and 8, you can do that by indicating it in this vector, okay? Before indicating the size of the matrix, say 3, okay? So here it will give you values found only between 5 and 8, and not necessarily between 1 and 8, okay? So you can do that also with Randy. You indicate the minimum value here and the maximum value. So you indicate the range of values you want your random integers to be taken from in order to form a 3 by 3 matrix, or in another case, a 3 by 2 matrix. Okay, good. So let's go back to our LinSpace. We had a LinSpace of A comma B comma n. Let me say n. So this simply tells you that I want n points, okay, n points that have, it's an arithmetic progression. Arithmetic progression means that the difference between the second and the first term is the same. The difference between the third and the second term is the same. The difference between the fourth, and it just goes like that. So the difference between the nth and the n minus 1th term is the same, right? So it tells you that you have give me n values, okay, that range from A to B, that form an arithmetic progression. Okay, so n values that form an arithmetic progression from A to B. It starts with A and finishes with B. Okay, or limit itself. It must not always include B, but no, it includes B. What am I talking about? It includes B. Okay, limit itself at B. Good. So let's look at that. Let me say 0 and then 5, and I say I want 6 points. What does that give me? You see, it gives me 0, 1, 2, 3, 4, 5, and that's a row vector. Okay, so the first term, it goes from 0, as you can see, right, to 5, as you can see, and it is 1, 2, 3, 4, 5, 6 terms, as you can see. So those are 6 points, right? And they are all uniformly distributed. They form an arithmetic progression: 1 minus 0, 1, 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1, and so on. Okay, so you can use this to, oh my god, this is so useful. It is damn useful. Okay, so let me take another one now. That will give us any kind of decimal value. Good. So here I have 1, 2, 3, 4, 5, 6, 7, 8 points. Okay, and if you, there is a command in MATLAB that enables us to calculate the difference the way we are saying it. Let me say difference of arms. Okay, and what do you see? You see the difference of arms. This command will take the first and the second term minus and give us the answer in the first column. Then the third and the fourth will give us the answer in the second column. And what do you see? It is exactly the same answer. Okay, so this forms an arithmetic progression, right? The last term is what? 7, and the first term is 2. Good. So we'll end here for now, and we'll see more functions. We'll see more functions again in the next section. Okay, so see you there.